Kia ora Year 12 and Year 11. Here's a really short video on two-stage factorising. Lots of practice at this skill in Theta 1502. Now when you first do this you're probably wondering what's the point, but it comes in very useful for understanding what we do when we factorise the more difficult quadratics, and we're going to get to that soon. So if you look at question 1 here, our first thing that we try to do is to find a common factor in all of these terms. We've got xy, xz, yw and zw. There's no variable in common in all of those. So the next thing we can think about is to take them two at a time and see if we can see a pattern here. So let's first look at the xy plus the xz. Well, we can take out a common factor here of x, so that's going to be x times y plus z. Now if we now look at the second pair of terms, and I really should have kept that plus sign in there with me, plus yw plus zw, I've got a common factor there of w. So we're going to take that out and we get plus w times y plus z. If we look at those two parts of the expression now, I've got x here times y plus z, and then I've got w times y plus z. So I've now found a common factor of y plus z. So the next step is to put it all together and write it like this: y plus z times x, there we go, x plus w. So that's how you do two-stage factorising. The next example is very similar, but you've just got to be careful with the minus signs. So looking first at all four, CE, CF, now here I've got 2DE, I haven't got a C, so I'm going to have to look at two-stage factorising. So let's take first these two. I've got a common factor in there of C, so it's going to be C times E plus F. Now we're going to look at the second pair. Keep the sign with the term, so minus 2DE minus 2DF. So my common factor here is going to be minus 2D times E plus F. So our final factorisation, I'll pop it up here, it's going to equal E plus F times C minus 2D. I've done two more examples on the next slide. Okay, exactly the same idea here. Start by looking for a common factor, because that's always easier. There isn't one, so we go pair by pair. Now sometimes you'll have to maybe rearrange the order of the terms, but for this first video I didn't do that. So I haven't got anything going on there, no common factors except x plus y, so we'll just write that one down again. But when we get to the next one, looking in here, I've got a common factor of minus z. So we'll take out minus z and then see what we've got. So minus z times y plus x, right, because I want to make x times z there. So now you can see more easily that I have got a common factor coming up here and here, and it's x plus y. So that should have an equal sign. So this is equal to x plus y times one lot of that, take away z. So that's now fully factorised. Same idea goes here in number 4. So have a look at this before you follow it through. The first term has got a 2x minus 3y times d plus e. And this part has something that looks a lot like 2x minus 3y. We could rewrite that second one, so here's 2x minus 3y times d plus e minus 2x minus 3y, right? Because a negative times a negative gives me a positive. And now I can see that I've got a common factor in the two parts of 2x minus 3y. So we can finish it off like this: 2x minus 3y times d plus e take away 1. Okay, that's all for now. Go do some 1502 for some good practice examples. Thanks for watching.